Hello, and welcome to this first episode of Tensar Ground Coffee. A few minutes on ground engineering to enjoy while having your coffee. So in each episode, we're going to cover a snippet of ground engineering that is usually somehow related to Tensar applications. Now, just recently, we've been doing quite a few tests on working platforms for piling rigs constructed out of our mechanically stabilized layer. We've been using the plate load test, but we've been using big plates. So why is it important to use a big plate when performing a plate load test on a working platform? Well, let's find out why. Brian, over to the flip chart, and I'll try to explain. So you have a ground level like that, a ground surface, and you have a plate load test. You all know what a plate load test, a circular plate that you put on the surface, you load it, and you measure the settlement. It can tell you the stiffness and the bearing capacity of this ground if you load it high enough. So the plates start off at about 0.3 meters or 1 foot diameter, but you can get bigger plates. Another common one, 0.6 meter diameter or 2 foot. Now, what difference does it make the size of the plate? Well, the depth of influence or the bulb of pressure is directly related to the diameter of the plate. So the depth here is up to about 2 times the plate diameter. So if you have a bigger plate, the depth of influence is going to be much greater. So even if this was all the same soil, you would still get a different result from this plate compared to this plate because you are testing a different volume of soil, and maybe the properties of the ground get different as you go deeper down. Now that becomes even more important with a working platform. Now you've got 2 layers. You've got the stronger working platform layer of compacted granular material. That's the working platform. And then underneath that, you have the softer subgrade. So now the bigger plate is influenced by this softer, weaker material. So we'll definitely get a softer, weaker response with this plate compared to this plate, which is only affected by the higher quality working platform material. That is important for working platforms because imagine we have a piling rig, for example, that is going to use this working platform, and that has a track width, say, 0.7 meters. What will be the depth of influence of that track? It will be similar to this large plate here. So clearly, to verify the design of this working platform and that it is safe to support the piling rig, you need to do a test with a plate that has a size, a diameter that is as close as possible to the track width so that the depth of influence is the same. So that if you loaded this to bearing capacity and verified the bearing capacity, you know you have sufficient bearing capacity for that plant there. That small plate is clearly inadequate to verify the design of the working platform because it does not have the correct depth of influence. This could be used as a quality control test just to check whether the granular layer is as was assumed in the design and has been compacted according to the specifications. But for verifying the design and the safety of the working platform, clearly you need to have a plate size as close as possible to the track width. So you see, when it comes to plate load testing, the plate size really does matter. Okay, that's all for this episode of Tensar Ground Coffee. Thanks for watching. See you next time.